ketone is typically named as alkanone. And in many of these molecules here, you see multiple functional groups in the molecule. Under that circumstances, we need to identify which functional group is of higher priority. On the right top corner of this handout, there is a list of functional groups and their priorities. And as you can see, ketone is relatively high in the priority group, and the alcohol, alkene, halide, and these are all of lower priority than ketone. Therefore, many of these molecules I listed over here would be named as some functional group substituted ketone. For instance, for this first molecule, it contains a bromine functional group and a ketone functional group. We notice that on the main chain, the carbon that bromine bound to is a chirality center, so we need to identify its chirality. And we also need to number the main chain. To number the main chain, we need to make sure that our highest priority functional group, in this case ketone, has the lowest possible number. Under that circumstances, we're going to number the carbon on the rightmost as carbon number 1, 2, 3, 4, 5. So the name of this compound would be R. I could put R in the parentheses. To save time, I just go ahead and skip that. 4-bromo pentane 2-on. Okay, the following compound has two functional groups, a ketone and an alkene. And again, when you number the main chain, the carbon that's buried the ketone functional group should have the smallest possible number. So we're going to number it from the right again. That'll be 1, 2, 3, 4, 5, 6. So this is a hexenone. Under that circumstances, we also notice that the double bond is a trans double bond or E double bond. So we're going to name this compound as E-hex 4-in 2-on. Okay, and really you could name this compound as E4-hexene 2-on. Either way would be fine. One is a slightly older version of the IUPAC rule, and the other, the one we're using right now, is the newest IUPAC rule. If you have more than one ketone functional group, you're going to name it as a dione, right? No surprise. Therefore, for this molecule over here, we're going to name it as 2,3-butanedione. And the following compound also is a dione, has two butane functional group and has two ketone functional group, and with the ketone functional group bonded to carbon number 2 and carbon number 4. So this would be our 2,4-hexene dione, or utilizing the more recent IUPAC naming system, we can name it as the hexene 2,4-dione. Okay, and the following compound is more complicated than the other example we've seen, and in this molecule we have a ketone functional group and we also have alkenes, and so we can name this molecule as a hexenone, right? A cyclohexenone, and we also have a number of functional groups. So first of all, we're going to make sure we number the cyclohexenol, and to make sure the ketone, the carbon bonded to your ketone functional group is numbered as 1, followed by 2. My 2 is kind of funky. 3, 4, 5. So we have another functional group on carbon number 5. Oh, another funky 5. So under that circumstances, the we're gonna make sure that we're gonna be able to identify those substituents. So we have a methyl substituent on carbon number 2. We have a relatively complicated substituent on carbon number 5. On carbon number 5, essentially we have a ethinyl. It's a alkene, but it's as a substituent, and we also have a methyl group bonded to the ethinyl. So as a substituent, if we number the substituent, and this carbon would be our carbon number 1, this would be our carbon number 2. So this substituent would be named as 1-methylethinyl. Therefore, to name this molecule, we need to identify that there is a methyl group on carbon number 2, and there is a substituent on carbon number 5, which needs to be named in identifying the substituent on the substituent. So there is a methyl on carbon number 1, and this molecule is a cyclohexene with the double bond on carbon number 2. Oops. Hexa 2 in. Oops. A dash. And we also have the ketone functional group on carbon number 1 on this 6-member ring. So that's the name of this compound.